if you solved this integral and came to this answer, you would have been wrong. And I'll go through the solution with you, and I'll show you exactly where you would have went wrong. So substituting in u for x plus e to the x is a good idea, because then your derivative in terms of x is 1 plus e to the power of x, and then you make a nice substitution for 1 plus e to the power of x dx to just be du, and you make a substitution for x plus e to the x to be u. So you reduce this integral to a much simpler integral that's easier to solve. And here's where the problem comes in. Taking the natural log of u. It should actually be the natural log of the absolute value of u, which means that this answer would have been the natural log of the absolute value of x plus e to the x. So what this does is, by taking the absolute value, we don't disregard values where this part of the function, x plus e to the x, or the input of the natural log, is less than 0 or less than or equal to 0. We don't disregard that when we have the absolute value, because the absolute value makes that greater than 0, and the input of a natural log has to be greater than or equal to 0. So this solution right here is the solution to this integral is this blue graph. And so this natural log of, if this was an absolute value, would be this blue graph. But because it's not an absolute value, it's only this part of the graph. It doesn't include the negative part of the graph, which is very important, because this 1 plus e to the x over x plus e to the x function actually has something that exists to that side of this value, whatever it is that lies in between here. And this value that lies in between here is the value where x plus e to the x equals 0. So what I'm saying is that the derivative of the integral is this function, 1 plus e to the x. So this function, 1 plus e to the x, should represent the gradient of the integral. So our integral, as this blue function, is both of these sides here. And so thinking of it in a reversely intuitive way, if our derivative exists to this side of the asymptote, then our integral must too exist over there. And that's why we have to actually take the absolute value of the inputs of logs when we're solving integration.